So if you look really closely at the ceiling of like a high-end casino or an airport concourse, you'll probably spot this small, unassuming white speaker.
Yeah, they usually just blend right in.
Exactly. But what you probably wouldn't guess is that a single one of those boxes, specifically we're looking at the QSC AD-S8T today, costs around $800.
Right, which sounds wild for just one speaker.
It really does. So welcome to today's deep dive. Our mission here is to unpack the intense engineering required to make massive public spaces sound flawless and figure out exactly what justifies that kind of price tag.
Yeah, and to figure out where that money actually goes, you have to look past the white plastic shell and look straight into the acoustic engine.
Okay, lay it on me. What are we actually looking at here?
Well, this unit is built to handle 200 watts of RMS power, and unlike peak power, which is just measuring these brief, sudden spikes of sound, RMS means this speaker can push that much clean energy continuously.
Like all day long?
All day long, hitting a massive 119 decibels.
Wait, 119 decibels. That is basically rock concert loud.
It is, but obviously if you're eating dinner under it, you don't want a rock concert.
Right. You want smooth, perfectly distributed sound so you don't even notice the hardware.
Exactly, which is actually much harder to achieve than pure volume.
Yeah.
So this speaker pairs an 8-inch woofer to handle the low end with a 1.4-inch compression driver.
Okay, and what does the compression drive do exactly?
It essentially squeezes the high frequencies through this narrow throat to project them further into a large room.
But if you have two different components pushing out different sound waves, wouldn't there be this messy middle ground where the highs and lows kind of crash into each other?
Yeah, you've just identified the crossover point. In a poorly designed speaker, that crossover point sounds muddy because the sound waves are radiating at different angles.
Oh, I see.
But QSC solves this with something called Directivity Matched Transition, or DMT. They physically engineer the shape of the internal enclosure so that the sound dispersion of the woofer perfectly matches the compression driver.
Right, at that crossover frequency.
Right.
So is DMT basically like adjusting a flashlight nozzle? Like instead of shining a wide floodlight and a narrow spotlight at the same time and getting a blurry overlapping ring, you get a perfectly even, crisp beam.
That is a perfect analogy, yes.
So there are no acoustic dead zones anywhere in the room.
Exactly. It dramatically improves what we call the off-axis response, meaning a customer standing way off to the side hears the exact same pristine audio quality as someone standing dead center.
Which is brilliant for maintaining that illusion of omnipresent sound. But all that delicate acoustic engineering seems like a massive liability in the real world. I mean, if you put this on an outdoor restaurant patio, wouldn't the humidity just destroy it?
You'd think so, yeah.
Wait a second. Looking at the source here, it says it uses a paper cone woofer. How can a paper cone possibly survive outdoor splash zones? Isn't that contradictory?
Well, it would be if it were just raw paper. But QSC uses a heavily weather-treated paper cone.
Oh, weather-treated, okay.
Yeah, it's specifically sealed to repel moisture. And the protection goes much deeper to earn its IP54 rating for dust and splash resistance. The outer shell is this rugged ABS enclosure.
ABS, that's like the tough plastic they use for hard hats, right?
Exactly the same stuff. And it's paired with a powder-coated aluminum grill.
But even the wiring connections have to be vulnerable, right? If a speaker is vibrating at 119 decibels for years, regular plug-in wires are just going to rattle loose.
Right, so they account for that using a 4-pole Euroblock connector. It's this specialized wiring block where the cables are physically clamped down with screws.
Oh, so they literally can't vibrate out.
They can't. And then that entire connection point is buried under a sealed weather grommet. Moisture and dust never even reach the sensitive terminals.
Wow. And the specs say it operates safely from -4 all the way up to 122 degrees Fahrenheit.
Which is wild when you think about the physics involved. The plastic shell, the metal grill, the internal components, they all expand and contract at varying rates when the temperature fluctuates.
Right, so engineering those materials so they don't warp and crack the acoustic seal over years of extreme weather is a huge part of what you were paying for.
Absolutely. Plus, they include this award-winning X-Mount system to guarantee zero slippage. So the physical box never slowly sags down the wall over time.
Okay, so the next time you're having dinner in a bustling restaurant or walking through a concourse and the background music sounds impossibly rich and clear, look up.
Yeah, you might just be listening to an engineered marvel hiding in plain sight.
But there is one final feature from the source that connects this to an even bigger picture. This speaker is designed to work with advanced voicing filter sets using QSC intrinsic correction.
Right, which is a software processing platform that mathematically corrects the physical acoustic flaws of the speaker.
In real time.
Yeah, before the sound even leaves the box.
So if we can now use software and digital processing to perfectly correct a physical speaker's flaws, it really makes you wonder.
Wonder what?
Will future architects just stop caring about the natural acoustics of a building entirely? I mean, why worry about the shape of a room if an algorithm can just calculate and fix the sound for you?